Guys, welcome back to QST YouTube channel. Today we are going to be solving the CA physics quiz for term 2 week 8 chapter 4.3 to 4.10. Okay, let's get started. Drag and drop the equation that relates to the moment of a force M to the arm of the moment D perpendicular and the magnitude of the force F. This is the most important rule like in these sections. Moment equals force times perpendicular distance. If you have not memorized it yet, please try your best to memorize. Okay, it's such a simple rule. Okay, let's go to the next question. Immediately here you can see where we imply this rule. Moment, as we stated in the earlier question, moment equals force times perpendicular distance. Here we can do like this. One second, let me make the text bigger. Here the force, like if I draw it like this, the force here, it will always be stretching out like this. Look, it will continue going like that. So the perpendicular distance from the force to A, vertex A, is 60 centimeters. But here they ask for newtons on meter. Here, if I'm not wrong. Yeah, newtons on meter. So moment equals force, which is 20, times 60 over 100. Because from centimeters to meters is divided by 100. Okay? If you put that into your calculator, you get 12. Alright? On to the next. Okay, here it says equilibrium. Like if you read the question, two downward forces, 25 newtons and 35 newtons, are applied to a uniform plank of weight 10 newtons. As shown below, the center of the plank is placed on the fulcrum and the two forces are applied, respectively 20 centimeters and x centimeters from the fulcrum. The plank is in equilibrium. There is a rule here. It's especially when it's equilibrium, okay? Net moment of counterclockwise equals net moment clockwise. Okay, so here it's going to be going from the axis of rotation. Here it's going to be going counterclockwise, and here clockwise. Okay, so what we do is the force is 20 and the perpendicular distance from the force to the fulcrum is 20. So 25 times 20 equals 35, the clockwise, okay, times x. So 35x. Put it into your calculator. You get 14.1. And that is the distance in centimeters. But if they ask you in meters, please convert to meters before you calculate. Okay? So here they ask for the upward force exerted by the fulcrum on the plank. Since it's at equilibrium, all the forces together are equal to the upward force. Since all these forces are going to be going down, you want all of them, add all of them up and make them go upwards. So it's because it's at equilibrium. So 25 plus 35 plus 10, as you can see here, 10 equals 70 newtons. That's it. They ask for significant figures. You put 70 point newton. That's it. Because you need to, for zeros, they don't count as long unless you put a point. Okay? On to the next. This is a really simple question. Moment of couples. Okay? This is a different rule. Moment of couples, it's not that different. It's really close. But the moment of the couple is equal to force times the distance between them. So here they ask for Newton on meter. So you do 15, because that's the force, times 2 centimeters over 100, because we need to convert to meters. Put it into the calculator. 15 times 0.02. You get 0.3. That's it. That's the answer. Alright, let's go to the next question. A pin is formed at a spherical tip of mass 7 grams and radius 1 centimeter attached to at a point A to a uniform rod AB of mass 14 grams and length 8 centimeter. So let me make the from A to there is 1 centimeter. The radius is 1 centimeter and it is 7 grams. All right, and here from here is going to be 14 grams, and they want the center of gravity. Okay, so it's going to be between these two here. Let's say we put it here at distance. 1 second, let me just move the 1 centimeter at distance x. Since from B to A is 8, this is the center, so going to be from here to there is 4. And here there's a rule. G1 over GGA equals mass B over mass A. So GG means the distance from the gravitational center, the center of gravity from A, and the gravitational center distance from B. So here we said A is from A to the, let's say, point G is x plus 1, because we're taking it from here, we're taking it from here, this point, over 4 minus x, because from here to here, from here to there is 4, and we want the distance from point D, for example, let's name it point D to G. So we do 4 minus x equals, from grams to kilograms here it doesn't really matter, because you're gonna do 14 times 10 negative 3 over 7 times 10 negative 3. Cancel out 10 negative 3, you're gonna get 7 over 4 equals 2. Okay, put it into the calculator. X plus 1 over 4 minus x equals 2. You get 2.33. Okay, so here what you're gonna do now, okay, you want to find the geometric center. You do 8 minus 2.33, because we want to find the geometric center. We found the geometric center from between those two. So now we need to minus that answer we got by 8, like 8 minus the answer. So you get 5.67. Okay, on to the next. Okay, this is like the first one we solved. Okay, so here the plank is at equilibrium. It's basically exactly like the first question. It's at equilibrium, but this time we want to find the force. Okay, so we use the rule net moment of counter equals net moment clockwise. Okay, 50 times 25. Again, they asked us we don't need to convert it because they're both on centimeters, equals 40x, because we're trying to find x. If you plug it into the calculator, you're gonna get 31.25 Even though you round, it's going to be 31.3 and 31. That's it. You keep it 31 because it's they want rounded answers. Okay, so x equals 31 newtons. Okay. The upward force on the plank, since we said it's at equilibrium, all the forces together that are going down added up. Okay, we add them all up. Here they said the weight is 20. So the weight of the fulcrum is 20 newtons. We do 50 plus 20 plus 31. It's gonna give me 101. That's it. As simple as that. Get 101 newtons. Alright, on to the next. Okay, this one is similar to the second question. Okay, the moment of F about vertex A, alright, go from here to there like this. Perpendicular distance is going to be 60 centimeters, alright? And they want it here Newton on meter. So all you need to do is 20 times 60 over 100. Cancel here, cancel here, cancel here, cancel here. You get 2 times 6, which is 12. This is the answer. Alright, on to the next. Okay, this one as well. Firstly, you can do this, like you do it this way. This is the axis of rotation, and the force is going like this. It's going to be moving this way, like that, around the axis of rotation, like this. So it's going to be moving counterclockwise. That's the first thing. So we know it's positive. Here we put positive sense. 0.2, because we want moment equals force times perpendicular distance. 0.2 times 20, 4. That's it. That's the answer. Alright, on to the next. Okay. Okay, this one is exactly how I said earlier. It's the upward force, so it's the addition of both of the downward forces together, of all the downward forces together to give us the upward force. Here the downward force is, we use weight equals mg. They give us gravity. So 10 plus 30, because we have 3 grams and 1 kilogram, 3 kilograms and 1 kilogram. It will give us 40 newtons. That's it. Alright, on to the next. Okay, the point at which the entire weight of a body is assumed to be concentrated is called the center of gravity. This is just the memorization, so I expect you guys to know this. Okay, let's go to the next. Okay, this one is easy as well. Okay, all you need to do is it's the same exact way I told you. Net moment of counter equals net moment of clockwise. Okay, we use moment equals force times perpendicular distance. The force here is weight, which is mg. Okay, we assume the weight is going to be 10 meters per second. You have to have it memorized. So we do firstly from here the distance from this person, which is 60 kg or 600 newtons, okay, to the pivot is 0.8. So we do 600 times 0.8 equals 400 times x. If you put it into the calculator, which I already put in, you're gonna get 1.2. Okay, so x equals 1.2 meters. That's it. Okay, on to the next. Okay, this one is simple. They said that A is the like axis of rotation about point A here. They said negative, which means clockwise. First thing we can say, Q is going to be 0, so we cancel it out. P, if we put the force like this, it's going to be going upwards like this. It's going to be going clockwise, okay? Because it's going to be going like this. You need to memorize the movements. This is clockwise. This is this is counterclockwise. This is clockwise. Counter. This is clockwise. Let me write it properly. All right. And R, if you do it like this, it's going to be moving counterclockwise as well, around the axis of A. But for S, it's going to be moving like this, clockwise. So it's going to be negative. As for T, it's going to be negative as well. So here we have T and S. So here and then, so that's T and S. Okay, let's go to the next. Okay, this one is easy as well. They want the net moment. Okay, first thing we can say is they said that about point A, so A is the axis of rotation. F2 intersects with it, so it's 0. Cancel it out. And force 1 is going to be going like this, and it's going to be half of AD, the distance. And they wanted Newton on centimeter, so we don't need to convert it to meter. Force 1 is 8, so we do 8 times 6, which is going to give us 48. We check if it's going to be clockwise or counterclockwise. Draw this, or just use your calculator. Make a force going like this. It's going to be moving around the point axis of rotation in a clockwise motion. So it's going to be positive 48. So positive 48 minus or plus, let's see. Force 3 is going to be going like this. One sec. Why is it not drawing properly? Like that. It's going to be moving perpendicular to this point there. Okay? It's going to be half of 10, which is 5. And force 3 is 4 newtons, 4 times 5. But wait, let's check if it's clockwise or counterclockwise. Draw a rectangle here. This is the axis of rotation, and a point going like this. Draw it around the axis of symmetry. It's going to be negative clockwise. It's going to be going clockwise. So it's going to be negative. 4 times 5 is going to be negative 20. So 48 minus 20. The answer is 28 Newton on centimeter. Okay, on to the next. This one is really easy as well. You don't need to stress. First thing, we can assume that the door stopper here can be the axis of rotation. Okay? And now we draw the forces acting. We have the force here of the pushing force, normal, and weight. Okay? The force is going to be going like this way, around the axis of rotation in a clockwise manner. Okay? As for normal, it's going to be behaving the same way in a counterclockwise manner. But for weight, it's going to be acting in a clockwise manner. So here they ask for what box will produce a clockwise moment, and it's going to be weight. And what is the conventional sign? Clockwise is negative. Okay? I'm gonna give you something really quickly. Counter and clockwise. Let me just draw the seat properly. Counter is going to be inwards. Wait. Okay, I went ahead and wrote it. Clockwise is going to be inwards and negative, and counter is always going to be outwards and positive. Alright? Let's go to the next. Okay, this one is easy as well. It's basically moment. First thing we can say, force 1 will not be making anything because it's intersecting with the axis of rotation, which is A. And force 2, which is going to be going like this, perpendicular to point A. Okay? And it is going to be force 2 is 20 newtons times, what is the distance, perpendicular distance? 6. But wait, we didn't make sure if it's clockwise or counterclockwise. Draw a diagram, or if you want to use a pen, with a point of axis of rotation here. Make a force going like this. It's going to be going like this, in a clockwise manner. If I hold my pen and put a force on the tip, so going bottom left, it's going to be going clockwise. So it's going to be negative. So 6 times 10 is 120, negative 120, plus or minus, let's see. Force 3. Force 3 is already perpendicular. And if you draw a diagram, or again, use your hand, it's going to be going in a counterclockwise movement, which is positive. And it's going to be force 3, what is it? It's going to be 6 newtons times 12, because from C to A is 12 meters, times 12. It's going to be equal to 72. Now they want the net torque. The net torque of force 1 is 0. Force 2 is negative 120. And force 3 is positive 72. Add them together, you get negative 48. Okay? On to the next. Okay, this one is easy. The magnitude created by the couple, of the first couple. Firstly, let's draw this from point A to there is 10 centimeters, but from up here to there is 15 centimeters. The magnitude of a couple, or the moment of a couple is force times the distance between them. The distance between them is going to be 30, because from here to here is only 15 centimeters. So from up here from point C to point D, if we make our own points, it's going to be 30 centimeters. Converted to meters, you do 200 times 0.3. You're gonna get 60. That's the answer. And it's magnitude, so it doesn't matter if it's negative or positive, it's magnitude. And force F on A must be directed in which direction? Since we said it's the net moment here is going to be 0, they're going to be opposite directions. So it's going to be, A is going to be going leftward and B is going to be going rightwards. Okay? And in the bottom, they're asking of the magnitude of force A. So force prime times the distance between them plus force times distance. Okay, since we said A is going to be going leftwards and B is going to be going rightwards, if you hold your hand up like you're holding, for example, the calculator on the exam, if you turn it to the left, it's going to be doing a counterclockwise movement, which is positive. And since the other circle is going to be doing a negative, an opposite direction, so it's going to be negative. So the inner spool is the movement of it is going to be positive, and this is going to be negative, the outer spool. So you're going to do from up here to there is going to be 60. We use the value we got, negative 60. Firstly, we do the force prime times the distance between them is 0.2 minus 60 equals 0. If I put it into the calculator, 0 0.2 times x minus 60 equals 0. I get 300. Okay? On to the next. Okay, this one is really simple. We just need to draw it. Okay? Here is we can plot it anywhere we want. Let's say I plot it over here. And the entire thing is 100 centimeters. And from here to here is going to be x. Here is the 40 kilograms. Here is 60. Okay, and the center of gravity of the system is located how many centimeters away from the 40 kg person? Okay, first thing we do is, since it's going to be in equilibrium, if you convert kg into, you make it weight, okay, so it's going to be 400, since 40 times mass times gravity equals weight, so it's going to be 400 x times x equals 600 times, in brackets, 100 minus x. If you put it into the calculator, equals 600 times 100 minus x is going to give you 60 centimeters. X equals 60. So this is the answer for the first one. And as we said, since it's at equilibrium, the force exerted equals the force exerted upwards is going to be equal to the force exerted downwards, okay? So here we said the weight was 600 plus 400, which is 1,000 newtons. Okay? Easy. Let's go to the final question. Okay, which a uniform square lamina is shown in the diagram below. C and E are midpoints of the sides of the square. The lamina is suspended from point A and allowed to hang freely. Which one of these segments will be vertical after the lamina is suspended? Okay, so it's going to be suspended around point A. Let's draw it. So, point A. Why is it not working? Okay. It's going to be suspended around this point. So you can just draw it like this. Let me just draw it in a nicer way. This is point A. It's going to be tilting downwards. B is here. C is here. This is B. E is here. And D is here. Which one of these segments will be vertical after the lamina is suspended? Is going to be A to B. Okay? And the weight of the lamina is 20 and the side of the square is 10. The moment of the weight of the lamina about A as it hangs freely. Here we can say, okay, since this is the perpendicular force, this is the perpendicular force B, it intersects with point A. So it's going to be equal to 0. So as it intersects with the axis of rotation. That's it. It's going to be 0 newtons on centimeter. Alright? Thank you guys for watching this video, and I wish you guys the best of luck for your exams, and have a great rest of your day or night. Bye.